that is Coriolis effect, and that is we are talking about.
Yeah, I know what the
So,
Coriolis effect is, and like I said, it's like an inertial
but
force. It's not a
it's not
real
a force;
force.
it's an
It's
illusion.
a.
Doesn't matter.
No, I know that. I
It
know
is a
that.
real effect, but we are not reserving. We are not getting that effect in real life. Therefore, it's because we are not rotating, and we are on the so-called rotating frame that we are talking about if the Earth is rotating. But because the Earth is not rotating, therefore we are not getting any Coriolis effect. And Coriolis effect is not a force; it's just a effect of illusion effect.
Do you understand? Yeah, yes, Johnny. That's what an inertial. That's what I'm saying. It's like a centrifugal force, depending on your how you want to your frame of reference. It's a force that could either be fictitious, or you could treat it as like a, or it can be. But if you were in the correct, if you were in a frame of reference where you're like, so if I'm outside of the Earth, looking at the Earth, let's say, that centrifugal force that I feel is a fictitious force because it's
Yeah,
just
but
my change in my direction. So I want to keep
yeah,
going straight, but the centripetal force due to gravity keeps me going in a circle. So I feel the centrifugal force which wants to launch me out of the Earth. So
I know
that's a
it.
fictitious force. So I know what that is. You're saying I
Yeah,
don't know
that's
what that is. I
exactly
do know
it.
what that
But
is. And that's the same thing with the Coriolis effect. There's
listen,
no
listen, now
force pushing,
you have
deflecting
to listen.
objects. It's an
Take it easy,
inertial thing.
take
Yeah.
it easy, take it easy. Listen, the
You,
difference
you
is
said you didn't want to be nice, but it's literally I've described what you just described, but probably better.
no, you're stop me. I'm just trying to tell you the differences. The differences is it's optical. Coriolis is optical effect, and that you are talking about is
Right, due
not
to
optical.
inertia, it's not an actual force. It's an inertial thing. Yeah, I explained it.
No, I explained.
No, I explained it. You tried to explain it,
No
but
me,
you
no
didn't even
me.
understand the terms that I was using. And they're the correct terms to use.
Centrifugal force is absolutely that you
It's
can
a fictitious force, yes. But
you,
depending on your frame of reference, if you're inside, you could treat it as a centrifugal force, and those, if you do like a free body diagram of the forces, it will balance out. So just because it's fictitious doesn't mean
you
it
can
can't be
feel it.
used to
You take
analyze
you
like a
take
static
it.
equilibrium or something like that.
You can really feel it. It's not
Yeah,
optical.
yeah, you feel it. Yeah. So depending on the frame of reference, you could either say it's a centrifugal
But
force,
you cannot
or you could
feel
see it as an
Coriolis.
inertial
You cannot
effect.
feel it. That's clear optical. So I am absolutely right about that.
Yeah, but I'm not wrong either. So
So that's not this absolutely the same thing that's happening.
okay. But okay, so what's the point? So you're saying that you could see that the Earth's not moving and there is no centrifugal force?
Yeah, Johnny. He gave an example about observing something from above and imagining the force, and one is by physically standing upon, which is then experienced by centrifugal force. And he
Yeah,
explained
exactly
both.
what I'm
Both.
trying to say.
Yeah, he
Yes,
explained both to
absolutely.
you.
Um,
That's exactly what I was trying to say. And you have to relax and think about what I'm trying to
Yeah,
say.
sure. Sorry about being hostile there. But go ahead.
There are differences there between the centrifugal force. That's not so much optical, and Coriolis is clear optical effect. Yeah, you
uh,
can think of it as a force, but it isn't. And
so just
everything.
to go ahead, John. Sorry, I didn't mean
Yeah,
to interrupt.
you can see the object above you if you're on a non-rotating reference frame. you will see it go in a bending path, but in reality, it's going straight. For example, that is illusion. So
Hey,
it's a
hey, Johnny. Johnny, do you mind if I try to help explain the way I try to explain this to people? Who was it that was saying that
Felix,
he thinks
Felix.
that Felix? Hey, what's up?
Yeah, me. Hey, what's up?
I've argued this point a lot, and I just put a couple of gifs in the side chat. You want to check those out, maybe, and it'll help explain what I'm about to tell you. What the problem is the Coriolis. People call it the Coriolis effect, and they think it's about the Earth moving separately from the plane, which it is, because that would be the illusion of a curved path from space or on the ground. You would see the plane curving if the Earth were spinning. Even if in the pilot, from the pilot's reference frame, he's just going straight. Like he could use a star as like a reference point, just dead reckon south, and then he would be going straight according to him. But then from space, it would look like it's curving because the ball would make it look like it's curving if it was actually moving. But the bigger point here is the displacement. Like if you're headed towards the equator, where it's supposedly spinning at 1,000 miles an hour, and the pilot takes off from a spot that it's only spinning 500 miles an hour. And you could, even if we let you beg the question with the conserved momentum of the 500 miles per hour that it took off from, and we say, okay, the plane's spinning with the Earth at 500 miles per hour, and it's going. That's why it doesn't like have the Earth like automatically spin out from under it. But the problem is there's a gradient of tangential velocities as it approaches the equator, where it's got to now be in perfect sync with the rotation of the Earth at the equator at 1,000 miles an hour eastward tangential velocity, and it wouldn't have that. It would only have the 500, arguably not even that, but it would, even if we give you the 500, it's not 1,000. So how does it gain the exact amount that it needs to be in perfect sync with the Earth rotating eastward as it's going in a southward direction to land on a runway that it treats completely as stationary? Even if the pilot were trained to catch up to the 1,000 miles an hour sideways tangential velocity that I would need to treat the runway as a one-to-one relationship with the plane, it would have to continue accelerating that extra amount as it's slowing down to land in a perpendicular direction. So it really kills the ball. Pilots can't be trained to treat the Earth as stationary and level, like all flight simulators train the pilots to do, and all training is just treated as stationary, fly point to point. You have winds in all directions that are moving you, and you can't conflate those with Coriolis because it would be a complete displacement. The city you're traveling to is going faster than you are when the pilot starts out. So he would have to be not only caught up to where the city is and be traveling eastward sideways somehow, which the plane's not made to do, to be in perfect sync. He couldn't just be caught up. It would have to stay in perfect one-to-one relationship. And you can't, and ballers don't even try to claim that the atmosphere is in a one-to-one relationship because we have fluid dynamics. So even if the atmosphere were carrying it, it would be in a one-to-one. And if the atmosphere were pushing it sideways to gain 500 miles per hour sideways tangential velocity, then it would never be able to fly against that force and not only that, but the pilot would be aware that he's being pushed sideways 500 miles per hour faster than where he started out from. It would be dangerous because the plane's not made to do that. So if you think that planes can just treat the Earth as stationary when it's actually rotating, then you got to think over this whole thing again because it can't be a ball. We know planes land safely all the time.
Okay, you're absolutely right. Everything that you're saying is absolutely right, but it has nothing to do with Coriolis again. So
doesn't matter how we define Coriolis. The displacement, the difference in tangential velocity is the real problem.
Johnny, hold on. So good point, new perspective, and it does sound like you understand the Coriolis effect very well.
It's kind of like the Coriolis displacement. The effect is just an illusion from space or from the ground.
Yeah, right. So you described it correctly. So like if you're in the northern hemisphere, you're going from a higher latitude towards the equator. You're entering into a faster. You're entering
ground
into
would be moving faster than where you took off from.
Right. And then if vice versa, if you're at the equator and you're traveling northbound toward the North Pole, you're starting faster and you're going into slower inertial zones.
Yeah, or if you jump into a jet stream and you're going supposedly faster, 200 miles per hour faster than the Earth supposedly spins, but that just all works on a flat Earth with jet streams making it just go 200 rather than 1,200.
Yeah. So that's a good point, and it shows that you understand it. So that's very good. But I would say, like, I'm not a pilot, but I imagine that what's happening is that the plane speed, right? It's not relative to the ground as much as it to the airspeed. So I think
What do you
that
mean? What do you mean by that?
okay, so planes in the sky, when they're flying, it's like their speed is really a function of the airspeed, regardless of what how fast they're going in relative to the ground. So I think they are like traveling with the air. So like if you were in a boat and you had that water stream going in one direction, then of course you'll go faster going downstream and you'll go slower going upstream.
Yeah,
And
those
I'm
are
not
easy
saying
concepts. That doesn't solve your
right,
problem.
right.
Actually, it makes
So
it worse. I'll tell you why it
right.
makes it worse.
Okay.
It doesn't answer it. And not only that, but even if it did answer it, there'd be so many estimations involved there. You can't just have a one-to-one relationship. You can't just treat the Earth as stationary unless there's a one-to-one relationship. You can't just say, "Oh, the air is pretty much carrying it this way," but then the winds are blowing it every which way. Do you get why that doesn't work? You can't. I mean, you're like the pilot can't have any kind of, okay, it's pretty much going to be in sync. It would have to be so in sync that it wouldn't even be noticeable that the ground's moving. You understand? Because
Mhm.
they can't land on anything going perpendicular sideways with a different vector. It would break the
Okay.
wheels off. If there was just a slight difference, it would break the wheels off. If it was even just a little bit more than slight, you would crash land and die.
Y-
So planes land
Yeah.
safely on the ground because it's actually stationary, not because it's actually moving and they're just treating it as stationary. Doesn't work.
Yeah, but wouldn't you say this new perspective? So like if I were to travel across a river, like not with the
I
stream,
know
or
about the river. That's just a non sequitur. I mean, carrying a
well well
plane, even if it was a
well,
river,
well,
you can't. The
well
river's just miscellaneousness to the
no.
carrying of anything, so it can't be an
So sorry.
estimation. Otherwise, the pilot doesn't treat it as
Oh,
stationary.
oh, yeah. Hold on. So no, I get what you're saying, but like I'm using the river as an analogy, so it's easier to
Yeah, but it's
visualize.
not. It's a non sequitur though, because it's not. It's not. The river doesn't have parts of the river pushing the boat backwards in the opposite direction, because winds go in all directions, right? So the flow
Right.
of the river is only in one direction, right? Now we can say
Okay.
predominantly it goes in one
Okay.
direction as far as the air goes, but we can't say that it's carrying a plane as well as being pushed in the opposite direction by winds. How do you separate the atmosphere from the winds, bro? What's the difference?
Uh,
Well, even that
okay.
is not.
Well, to answer that question, like, and I'm not saying that I'm right. Like, this is a feel like I don't know. Like, I'm not sure. I'm but what I would speculate is happening is that you have like a combination of like you'll get turbulence. That's the reason for turbulence, and it might depend on the density of the air. But I would garner to guess that the Coriolis effect, the Coriolis displacement, if you like to call it, it does give rise to at least some kind of wind pattern where we have easterly and westerly winds. So there is a consistency in terms of if you're flying west, it's faster versus if you're flying east. I don't know actually which way is faster, but it is faster going east to west or west to
Well,
east.
that's due to
It's
jet streams,
longer,
though.
right? Right.
That's
So,
due to
but
jet streams.
right, right. For i.e. jet streams is
So
one.
one of the things I made sure to point out when I did, I know I went through a lot of points, but one of the things I
Yeah.
made sure to point out, and I'll do it again, the
Mhm.
winds are a completely different thing to deal with than the Earth rotating underneath the plane.
Right.
Totally different.
Okay.
Two different things. When a plane lands and it has to deal with winds, you see
Right.
like the plane having trouble landing on the stationary ground when it's winds blowing it back and forth. If the ground were moving consistently 15 degrees to the east and it was trying to land, it would have to deal with the ground moving and the winds pushing it. That'd be two things to deal with, right? And it
Yeah.
doesn't,
Right.
because if the ground weren't stationary, if it were actually moving, then not only would it be like impossible for the plane to be in perfect sync because the ground's moving and it would have to go sideways with the ground so much in sync that it doesn't even seem like it's moving, right? Which is impossible because it also, even if it could be in sync, it would have to continue rotating sideways as it's slowing down to land in a southward angle, right? You're landing and stopping and then also continuing to move with the earth. Do you get how that would not work?
Yeah, but honestly,
It has to go
I could see,
sideways. You get it?
yeah, I could see how that wouldn't work on like a small ball with a small radius. But if
No,
you have
any
a very
ball, any moving surface. It doesn't matter if it's a ball even. Just if the surface is moving left to right and you're going down in the opposite perpendicular direction, if the surface is moving at all, bro, you're going to break your wheels off and crash. Can't be moving. It proves there's no
okay,
ball. I know you really
okay,
want to believe in the ball still, and it's hard to
yeah,
just
it's
say
okay. No,
there's
it's
no
all right.
answer.
No,
But when you look into this, there is no answer to this. They just conflate it with winds and say, oh, the winds would be so much more stronger than this Coriolis thing that we like to minimize. Dude, we're talking about 1,000 miles an hour at the equator. Just if it took off from a place that it was only moving supposedly 500 miles an hour, it has no gauge of moving sideways 500 miles an hour to begin with. That should tell you something. But the idea that the winds are going to carry it the exact amount so it could treat the Earth as stationary when it gets to a city that's on the equator is not even like plausible.
Well, I can see how you'd think that.
Yeah, but you could say I just think it, but you don't have an answer for it.
No, I can see how you can fail to understand that. Yeah. If
Yeah, go ahead and tell me what the mechanism that makes it perfectly in sync 500 miles per hour faster eastward. You tell me the mechanism instead of criticizing
me.
If
you'd shut up for half a second, I'd be glad to.
Okay, I'm done. Go ahead. You got answers.
Right. How fast is the atmosphere moving at the equator relative to the Earth?
I'm not going to start even answering your questions. You just tell me the answer.
Well, that's the answer. That's the answer.
It doesn't make any difference.
That's the answer, and I'm sorry you don't understand it because it's really simple for anybody with a moderate bit of intelligence.
There's a question that I didn't even hear. What's your answer?
The answer is the atmosphere is moving with the Earth at the equator. It's moving with the Earth at the 45-degree latitude. So as the plane flies south towards the equator, it picks up rotational velocity from the atmosphere that it's flying through.
I already went through that answer, though.
No, you didn't. But you misunderstood all of it. But you misunderstood all of it.
First of all, I'll give you all the reasons that it doesn't work, right? Then you can tell me why.
They're all wrong.
No, they are not wrong.
They're wrong.
Let me just go through it really slowly because I pointed out that you would give that answer, or someone you would usually give that answer, as if the atmosphere would be actually carrying the plane sideways perfectly to be in sync with a one-to-one relationship. Like, first of all, would the pilot be smart to put his faith in an atmosphere carrying the plane some miscellaneous amount so that he can treat the Earth as stationary? Like, that would be ridiculous. If the atmosphere could do that, it would be ridiculous to even think that's possible with the winds moving in all directions and the variations of winds, because we have fluid dynamics to begin with. No baller that has any respect any longer.
That's just words. What does that mean?
The words are that fluid dynamics is a real thing, bro.
I know
fluid dynamics means it's not in perfect lockstep.
Yeah, if you know that, why you are asking that it is not possible?
Well, I'm telling you exactly why it's not possible.
No, I'm not asking you. I'm not.
Ripcord, because it means nothing. It's meaningless words from him.
What? Do you think that fluid dynamics isn't a real thing? It's just words.
It is, but you don't understand it.
How do you have 3 or 4 different streams at the same time?
Let me just argue this, please. Please let me just argue this, because I've already went through this, and he's acting like I didn't know what I was talking about. I'm about to show him that I do, right? Because you said the atmosphere would carry the plane to be in a perfect one-to-one relationship, when fluid dynamics doesn't even allow the atmosphere to be in a perfect one-to-one relationship.
Explain that.
You have to admit that.
Why not?
Because fluid dynamics isn't going to be, because first of all, dude, it's ridiculous that you even think that. I don't even know how to begin.
Why not?
Because fluids, right, aren't going to be Velcro to the Earth. There's a variation. There's fluids. That's why they call it fluid dynamics, right? And the winds go in all directions. So where's your fluid dynamics pushing the plane in one direction to begin with? Not that it would work anyway. It's not an answer. You don't have your magic refraction answer that makes
we're not talking winds.
You really think through the common sense.
This is where you misunderstand things again. We're not talking about wind.
Oh, yeah. Well, what's the atmosphere pushing the plane if it's not a wind, right?
When the atmosphere,
how would the atmosphere push the plane? What do you think anything pushing the plane sideways would be called? If not a wind, air pushing the plane is a wind, technically.
No, it's not.
Oh, really? Okay. What is it called? Well, what's the mechanism that makes it push the plane sideways then?
No, we consider when the atmosphere is moving with the Earth not to be a wind.
What do you call it, though?
That's the definition of not wind. Wind is when the atmosphere is moving against.
So not wind is carrying the plane.
Yes.
So wind is what you're saying. Don't worry, folks. We're going to have a safe landing. The not wind has carried us perfectly in sync with the Earth at 500 miles per hour sideways. Don't worry. We just put all our faith in this magical atmosphere. No, it's an equation. It's a kinematic equation that allows you to just subtract that factor so you don't have to think about it. In fact, you have people on your side that are real pilots saying that there would be the same exact training for a pilot to fly over a stationary level Earth as it would be for a spinning globe Earth, right? Yeah, so they think that it would be no difference, right? Because kinematically, you can just subtract that out of your mind and say, oh, we can mathematically say it doesn't exist. No, dynamically, in the real world, there would be a 500 mile per hour difference where the city is that it's landing in and where it took off from. And you can't just say magically it just gained it because we think the atmosphere does it automatically magically.
No one's saying magically. We're saying the atmosphere does it. Yes, that's what happens.
Mathematics doesn't apply here, dude.
You want to share that math?
The pilot had to.
You want to share that math?
Plane.
You say you got the mathematics. Share the math. You just said math.
No, I said you're saying math solves it. It doesn't. You have to have a dynamic situation that you're explaining with a mechanism, not just a math equation.
The math solves it. It's not our problem.
I understand.
It's not our problem. You can't understand the math. That's a you problem. That's a you problem. You don't understand the math.
You can say that. You can say the math is what you rely on, but the pilot would have to make the plane go sideways. Math isn't going to do that for the pilot.
No, they wouldn't.
I guess bring it on.
No, they wouldn't.
The math and let us go through it.
The math doesn't have anything to do with it. This is a common sense argument. The plane can't
but that's your problem.
500 miles per hour sideways tangential velocity. How does it gain? You can't gain momentum to begin with. You actually be losing momentum rather than gaining any momentum. But even if it accelerated, it would accelerate perfectly from the tail to the tip. Sideways.
Why would you lose momentum?
It's a perfect thing with the Earth, right? So you're saying I don't understand this, but you're just backing away.
Why would you lose momentum?
Because if you're going to lose momentum by forces acting on the plane, right? It's not going to keep going sideways eastward with the Earth, no matter which way it flies and no matter which way the wind blows it. It's going to lose momentum as soon as it gets in the air.
Try to be specific.
It can turn around and try to land on the same exact runway it took off from and still not be okay. Because when it goes up in the air, we have a greater circle, right? The ground is one circle. It's a smaller circle. When you go up in the air, you have a higher altitude. That's a greater circle. That means the plane would automatically have to be flying faster sideways to keep up with the perfect one-to-one relationship.
How much faster?
Which it wouldn't.
How much faster?
These are all common sense, dude. Common sense kills the globe here, dude. Doesn't have anything to do with
any common sense. If you had common sense, you wouldn't be a flat earther.
Yeah, so that's your anti-flat earth attitude that makes you look stupid in the end because you think I'm stupid. That's hilarious.
Do you not understand that the pressurized system and the gas is working on the globe?
Land on a surface that's moving when they're treating it as stationary.
No, the rest of us understand this.
No, you cancel each other out.
Would it work or not?
Yes, it would.